Hi folks, this is the 10th problem of the DSA series, so let's get started. It says 2 integer sum. Okay, given an array of integer numbers that is sorted in non-decreasing order, funny way of saying increasing order, return the indices of two numbers such that they add up to a given target number. Target and index 1 should be smaller than index 2. Note that index 1 and index 2 cannot be equal, therefore you may not use the same element twice. There will always be exactly one valid solution. Okay, so here we already did two sum in our third problem. However, this is little bit different because here we got a provide a solution with O of 1 space complexity, right? And one more thing, here we have been provided an sorted array. Here the array had random numbers and was not sorted. Here we are provided with a sorted array, that is array in increasing order, and we have to solve this two sum problem. That is, we have to provide the index of two numbers from the array whose sum is equals to the target number. Okay, so let's do it and you'll understand better. Function to sum, here we'll do target and here we'll say nums array, the array that will be provided to us. Now what we can do is we can simply say we'll simply use the pointer approach here since the array is already being sorted. How? Let me just show you. We'll say let left is equals to 0, that is the left index to be 0. Let right is equals to nums dot length minus 1. This is the right index of the array. Now what I'm thinking is we'll move the left pointer as well as right pointer depending on the sum, right? So we'll say while left is smaller than right, then do this. Okay, now you'll say if just bear with me, you'll understand while I'm doing. If let's say sum, first let's call sum is equals to sum of the element present on the left index plus element present on the right index. Okay, nums. Okay, so this is what sum is. Now if sum is equals to target, that means all is good, not just good but awesome. All is awesome because we have found the two numbers adding which we'll get the target. So we'll return the index of those numbers. Okay, so here we'll return left and right. That's it. Now one more thing, it says it's a return the indices one indexed. One indexed means we have to add 1 in both the indices. That's it and nothing else. Now however, let's say if sum is not equals to target, we are adding the number at the extreme left, the number at the extreme right, and if their sum is not equals to target, and let's say if sum is smaller than target, that means we got a move. But what we should move? Should we move left index or right index? Think logically. No, if sum is smaller than target, that means we have to increase the sum, right? And hence we got to move the left index to the right side, that is we got to increase the left index, right? So we'll simply do left plus plus, so that we'll increase the sum. Okay, because if we move the right index, that is decrement from the right index, this sum will decrease. However, if we increment in the left index, the sum will increase. That's why we incremented 1 in the left index. Now one more condition is left. If sum, what if sum is greater than target? What if sum is greater than target? That means we have to decrease the sum, right? How will decrease the sum? We'll simply decrease the right index. So we'll simply say right minus minus. Yeah, that's it. Now this should give us the two numbers, the sum of which should be equal to the target, right? However, if it doesn't, we'll simply return null here. Now let's test it out very quickly. To sum, and let's write this 1 2 3 4 and target is 3. Let's see what it gives us. It gave us 1 and 2, which is correct. Okay, so yeah, it is working. Now let's get into the time and space complexity. Time complexity here is O of 1 because we are iterating over the whole array. No, sorry, time complexity here is O of n, right, because we are iterating over the whole array. However, the space complexity here is O of 1 because note that we are not storing anything other than these left and right, and these are constants. So yeah, the space complexity is O of 1. So I'll push this code to my GitHub and give you the link of the solution in the description. And yeah, that's all from my side. Thanks for watching, guys.